An aha moment. That feeling you get when you finally understand something that you've been curious about for a long time. When I was little, the TV was on all the time in the background of my daily life. The channels varied between news, sports, and educational shows, and sometimes space shows would be on. I first started watching them because of the calm, intriguing voice that explained the colorful and explosive pictures on the screen. But as I got older, I began to pay attention to the science part. Planets, stars, black holes, galaxies, and everything in between began to take shape in my mind, and I became fascinated. However, I'd always envisioned everything as the size of household objects, things that could fit in the palm of my hand. I couldn't have been farther off. A few years ago, in a science class, we started learning about molecules and atoms. I was intrigued that everything in the universe is made up of particles so tiny that scientists had to invent an entirely new type of microscope just to see them blurrily. How does this happen? How does this work? And that's where my somewhat obsessive research began. I began small and investigated molecules and atoms first. Molecules are a group of atoms, and they are the smallest unit of that chemical. Atoms are the smallest unit of that element. And once we understood this, we were able to make revolutionary discoveries in chemistry and physics. I progressed to planets next. Planets are pieces of rocks or groups of gas that orbit a star and are sometimes orbited by moons or asteroids, which form together to create the illusion of much bigger objects, like the rings on Saturn. Every one of these celestial bodies has untouched resources that, if harvested, can be used to create something bigger than humanity has ever built before. We could alter a planet to make it fit for life once we understand how to generate a chemical reaction that big that changes the soil and atmosphere composition. I hope you all know what a star is and that we have one just an AU away. Our sun is a yellow dwarf star, and despite its small size, it's powerful enough to fuel all life on Earth. It's also large enough to fit 1.3 million Earths inside it. Every star has two main types of light, UV light and infrared light. UV light causes sunburn, and infrared light is what solar panels use to create electricity. This fact makes colonizing exoplanets that much easier because we can power our space travel by solar energy. A black hole is a region of space with a gravitational field so intense that no matter can escape. Black holes are the largest single things in the universe, and they range from something as small as 3 times the mass of our sun, or about 15 miles in diameter, to something as large as many times the width of our solar system. Take Ton 618, for example. Ton 618 is the largest known black hole, and it spans about 2,600 AUs wide, or 2,600 times the distance from the Earth to the Sun, which totals at about 242 billion miles in diameter. Black holes release about 40% of the matter they consume as radiation. A black hole as large as Ton 618 consumes about 1 solar mass, or 1 sun, every 2 days. So that means that every day, supermassive black holes release 20% of the sun's mass as powerful radiation. In theory, if we could harness this energy, we could sustain an entire planet for years with an almost unlimited energy resource. Once we understand more about black holes and how they work. Once we understand the universe, we can use the millions of resources it gives us to their fullest extent. We could become a multi-planet or star species, and if we can spread out like that, our field of vision increases. And if we can spread out like that, our field of vision increases, and we can discover more things, such as what lies at the end of the observable universe. We can find out why galaxies move the way they do, what's in the middle of a black hole, and what dark matter is. If we don't understand, we can't get better. Before 2000, the biggest achievements in space exploration were the events of the space race, sending Voyagers 1 and 2 out of the solar system, and landing rovers on Mars and the Moon. We could have given up and said, these are amazing achievements, but we don't have to do anything else. Thankfully, we did. Since 2010, we've grown food in space. We've recorded sounds from black holes and planets. We've landed on the far side of the Moon. deflected asteroids, and looked into the universe with our most powerful telescopes. And NASA has many plans for the future. They plan to explore the ice giants, Uranus and Neptune, to a much fuller extent. They plan to send probes to 5 of Jupiter's moons to examine them for life and land people on Mars. But none of this can happen if we stop trying to understand. The big advancements we know are coming can only happen if we continue to learn and exploit our assets. It's our duty to join the quest for knowledge that started when the first Homo sapiens journeyed across the Earth. Since the beginning of the human race, almost everything has changed, but one thing stays the same: our curiosity about the world around us and beyond. We owe it to our ancestors to properly use the information they have already given us. So why stop now?